Hi, this is an original Game Boy, and this is the same original Game Boy, only way better. And today, we're going to show you how to go from this to this, today on Hammer Tinkering. Let's go. Alright, this is going to be our starting point. This is an original Game Boy. Nintendo produced these from 1989 up to, I think it was the early 2000s. And this was a huge seller for them. At the time in the mobile gaming market, there were some other things. Their most major competitor was the Sega Game Gear, though, and this outsold the Game Gear by a pretty substantial margin. The reasoning for that being, even though the Game Gear was more technologically advanced than the Game Boy, the Game Gear had a couple of major downsides. The Game Gear was probably Nintendo Switch size, so in terms of being portable, not terribly so. The Game Gear also had a very short runtime of about five to 6 hours on batteries, whereas these could run for about 30, depending on the game and how intensive it was. Now, there's one major downside to these Game Boys, and it happened on this Game Boy and the next two generations of Game Boy after it in the US, and that would be this. Now, you can see the screen okay here. I've got decent daylight, but you get into a dark zone where there's not enough light and you can't really see anything. The reason for that is there's no backlight in these screens. That's how they achieve such amazing battery life. Now, I've owned this Game Boy for about 10 years at this point. I've played it, I enjoy it, but the backlight, no backlight in the screen is really starting to drive me crazy, and I want to do something about that today. So that'll be one of the modifications that we're going to do, is we're going to add a backlit screen to this, among some other things. Before we do that, we need to do a teardown on this and make sure that everything's running correctly, including to this Pokemon Red cartridge, which should have a battery in it. And I'm going to guess at this point, based on its age and condition, that this has never been opened and the battery's never been replaced. So we're going to have to get in here and do some soldering, put a new battery in. Okay, let's start with tearing this down and checking its condition internally. First thing we're going to need to do is we're going to need to take the batteries out of this. And we'll take a look at the battery contacts in here. You'll see these are in okay condition. When I got this Game Boy initially, somebody left a set of batteries in this, and they had leaked all the alkaline out everywhere, and there was quite a bit of corrosion and tarnishing on these, which I used some distilled white vinegar to soak all these contacts in and get them cleaned up. They cleaned up pretty good. Game Boy's been functioning just fine since then. Obviously, these are all going to get replaced today. Alright, now we can start taking the back shell off. And if you look down here, you'll see a funny looking screw. Well, that's because Nintendo, in their infinite wisdom, decided to use a proprietary screw for a very long time. I've seen these on their consoles all the way up through the Nintendo Wii, I'm pretty sure. This is called a tri-wing bit. So if you decide to take something like this apart, you will need a set of tri-wing bits, which I just so happen to have. So there should be a total of 6 screws on the back here, 4 on the outside, 2 underneath the battery case. We'll go ahead and take those out now. Okay, last screw out. Now we can go ahead and crack the shell apart. we're going to have to use some care with that. The right way to do this is from the bottom side to swing it open, sort of like a book. And the reason for that is I've got a ribbon cable here to contend with that connects between the power and processing boards and the I/O and display board up front. So we're going to go ahead and undo the ribbon cable so we can split the shell entirely. There we go. That's taken care of. And we've got the back shell. This is the processor and the power distribution board. We've got the board down here for the headphone jack. And I'm not 100% sure what this board is, but we'll go ahead and get the rest of the way apart and figure out what's going on here. And then on the other end, we've got the I/O and the display controller board and the speaker and the ribbon cable tied to it. Alright, most of what we're going to do today is not going to require anything that's left on here, so we're going to go ahead and set this aside for the moment. We will come back in a little bit and take this apart just to show you what's going on the other side of this board. Alright, now you can see from the back side here, once you've got it open, everything else internally is standard Phillips head screws, so this is not going to be real difficult to get apart. Go ahead and get ourselves out a Phillips bit and then start taking this apart. Alright, we've got ourselves a Phillips head number 1 loaded up here, so we should be able to start taking this apart. I'm pretty sure, aside from the audio board down here, which we'll need to remove these screws as well, this board is held in with just this pair of Phillips head screws. Let's go ahead and take those out. Just in case anybody was curious. Those screws are both of the same length, so you can use these interchangeably between the different holes. Got all the screws out. Go ahead and pull this off, and then the board should just come right on out. Easy peasy. Flip it over. Got the cartridge connector, all the processing on the board. DC in so that you can run it from an external power adapter. Game external connector so that you can do a game link between two Game Boys. Go ahead and take that out. Control for volume level, and then the power switch. So sort of a reference, let's go ahead and take the original I/O board off of here so we can take a look at what's going on. We should have 1, 2, 3, 4, looks like 6 or 7 screws here. It's actually a total of 9 screws. It's still pretty early in the morning here, so I don't exactly count well this early. Okay, I should just prise on out of here. Looks like we've got, this is nice, got some little latches on here to keep it in place after you've got screws out, so we'll have to pop those in. Well, when in doubt, grab the right tool. There we go. Alright. That popped open, got this popped out. Now, Before I flip this over, look at that, you can see right through it. And that's because these old DMG Game Boys, the display is soldered directly to the I/O board, which is not something that you'll find on the new one. Now, the new one did not come with a speaker, so we're going to have to reuse this one, which means that we're going to need to get out some soldering equipment to take this off. Okay, before we move on, just wanted to show you guys something on this. This is one nice thing about electronics from this particular era, was they were very good about leaving notations on the boards with silk screening as to the values of things that are supposed to be here. So you'll notice, like up here, this is listed as 10 microfarad at 16 volts. And all the capacitors on here are listed with the same notations. So if I need to do some work to this board, I don't need to go through and check a service manual as to what goes in each spot. It's all noted here for me already. As far as this board down here, this is the DC to DC converter board. That was the one that I couldn't identify earlier. Okay, with that, this is the main part that we're going to reuse out of this. Let's go take a look at all the new parts that we're going to use. So the parts that I got to do these mods all came from the same website. I got these all through a website called handheldlegend.com. They are not sponsoring this video. I paid for all these parts. I just wanted to give a shout out to them because they actually had very good guide links on each of the parts as to what things fit with others, which I found very helpful. I chose to go with a translucent blue shell. This translucent blue shell did come with new pads and buttons. I'm not going to use most of these with the exception of the new external connector cover port, or port cover rather. And then we've got a new power converter board and a 3000 milliamp lithium-ion battery. This wasn't really necessary, but for the sake of bringing this up to date and the sake of convenience, so I'm not burning through AA batteries, this is really nice to have. The one big thing about doing a conversion on this where you're adding a backlit screen is you're going to chew through batteries faster because the backlighting does have more power draw. So to switch to a rechargeable pack just saves on batteries. And we've got the new back cover that goes with the power converter board as a hole for the USB-C connector so you can plug in and charge without having to take the back cover off. We've got orange buttons and we've got white pads, going for sort of a golf racing theme with this. And the very last thing that we have here is the new LCD. Now, the new LCD comes with a couple of things. Let's see if I can get those out. It's got a new interface board in it. New connector to connect the I/O board to the CPU board on the back. New I/O board. And this is a little bit different. Well, it's clearly very different from the original I/O board, but the big thing to note about this I/O board is designed specifically for this, for the backlit LCD, and the reason for that is, you can see we've got some push button action on here. This is what the contrast wheel would have been on the original display, but this has got some extra functionality, so it's got a press button along with the crank wheel. Go ahead and set that aside. And then we've got the backlit LCD. Now this is very, very different from the one that was originally on here. It's not just that it's backlit. This is backlit. This has got color on it. And this is what's called an IPS display. I won't get too much into the technical jargon on this, but the big difference between the original display, which was twisted pneumatic, and this display, which is IPS, is that you get better viewing angle on this on both sides because of how this is assembled and developed. Alright. Now let's go ahead and start putting this together. Alright, reading through the notations on the installation notes for the LCD, it looks like the very first thing that we're actually going to do with this is install the LCD. As a notation on here, this LCD is actually designed to work specifically with these replacement shells. The reason we're going to do the LCD first is because high pressure on this LCD assembly could cause the LCD to crack. So we're going to go ahead and get that placed in here first just to get it done and out of the way before we're jostling with anything else. Right. Got the connector down here. It looks like we've just got some film that we need to take off for things to stick. There we go. Now I'm confident we've got it in place. Alright, and that just adheres right on into the shell like that. Good deal. Go ahead. Actually, I'm going to go ahead and leave that film on while we're working on this, just so I'm not getting fingerprints all over it. Alright, with the screen in, the next step in this little adventure is to get the display controller board mounted. That's done with this little connector down here in the bottom left-hand corner up against the connector here in the bottom left-hand corner. Now there's no circuitry on the back, so nothing can short here, but I also don't like the thought of this just floating around in here, so we're going to get out some Kapton tape, roll it around itself to create a double stick surface, and then stick this down. Here, Kapton tape. Cut off the front end of that there. Now the nice thing about Kapton tape is it is both electrically and thermally insulative, so this will not transfer heat and it will not conduct electricity, which is why it's used a lot in electronics. Around itself there, got set up to be a piece of double stick, stuck to the side there. Before we stick it down, we'll need to get the connector for the screen connected up here, which looks like that will be easier said than done. They use these connectors a lot in smaller electronics now. I do like these better than the standard flip-up connectors that they use on these. The retention mechanisms on these are really easy to break off if you're not careful. Alright, so we're stuck on there. So now, if we're doing things right, we should just be able to stick it right down to the board there. Okay. We're on, and if this is in the right spot, then when I go to grab the I/O board from up here and set it in, that cable should line up. Where are my holes there? Yep, that looks like it does, so we're in good shape there. Now the other thing that we're going to do before we put on the I/O board here is this all sits, we have electronics on this side, We've no electronics on this side, so we should not have any points of contact where we can short it. And I just wanted to make sure of that, because if there was potentially something that could touch this board and short, we were going to cover this with Kapton tape, but I don't think that's necessary. So it looks like the next thing we probably need to do then is go ahead and grab our pads and buttons and get those populated in here. All right, let's do that next. Okay. Buttons, pads, and most of these pads go on over top of the buttons. One of these pads, though, doubles as the button itself. So this pair of pads is the start select. And that's got one hole in it, which lines up with this peg on the shell. So we'll go ahead and get that put in. Should just sit right on in there. There we go. Okay, that's one. And we've got the AB pads, got holes here, pegs on the shell. This is reversible, so you can put this in either orientation and it should sit in okay, but we can't put that in just yet because we have to actually put the buttons in. Here, AB buttons. You'll see that these have some pegs sticking out on the sides. If you look in the shell, we've got slots right there. These do not have the AB labeling on them, so you can put these in interchangeably in either slot. Okay, buttons in, and we can put the pad on. Sit down on the pegs here. If I can get it to play nice. There we go. Alright, so that's the AB buttons. And then we've got the D-pad. It does not look like this has any sort of directional alignment, so this should go in any orientation. Okay, it goes in there. And we've got the D-pad pad itself, which looks like it has two holes in it. Should be reversible and goes up against those pegs. All right, we have that populated now. So that should be everything on this side of the shell, with the exception of the I/O board. Before we can actually place that in, we need to go desolder the speaker from the other I/O board and then go ahead and solder it into this one, and then we should be able to place it in just like so. So let's go get those tools and give that a go. We have the I/O board back in front of us, and what we need off of here is the speaker. This is soldered onto the board from the opposite side. When you're doing soldering on electronics, you've got a few different options you can do when you're trying to get things desoldered. Your options generally are desoldering wick, a desoldering pump, both of which are good for components like these capacitors if you only need to do one at a time. These are rigid, so you definitely want to try and get all the solder out of the through holes as you can before you go to pull them off. You also have, if you're going to be doing a large number of components on a board, you can get what's called a desoldering gun, which has a built-in vacuum pump on it and a hole through the soldering end so that you can just stick it down on and it sucks the solder straight out. In this case, because we're through hole with just wires, we can just use a standard soldering iron. Since this isn't a rigid device here, since it's just wires, I've got that heated up already. We'll get that tinned up here. Alright, we got the lead tinned up. Now it should just be a matter of a little solder on the end here. It actually is working very well. There we go. One speaker. Okay, now we should be able to grab the I/O board from the new one and solder the speaker back into the same spot. Now, we're going to pay attention to the orientation that this is in, because we pulled it out from the opposite side here. This will be the same way that we go and put it back in. There's one wire, there's two wires through. Just set that down there very carefully to make sure that they don't come back out. Stuff up in to frame. It should just be a matter of there we go. We might have gotten just a little too much on that lead. See if we can get a little of that back off of there. There we go. Pretty satisfied with that. Put that away, and we should be done with the soldering iron for the moment. Now, before we go ahead and put the I/O board in here, just quick notation. You'll notice I ran through this pretty quick. I did not make sure which lead went into which hole. And the truth of the matter is on that, it doesn't really matter. For anybody that knows anything about how speakers work, if you wire a speaker in backwards from the way it was, all that happens is it runs 180 degrees out of phase, which means that it vibrates backwards from the way it normally would. On something like this, it's really not going to matter. Alright, let's go ahead and put the I/O board in. Speaker down in there. Looks okay. I/O board is on. Okay, now we need to get some screws out. So this kit actually came with its own screws, and for the most part on the internal components, I'm going to go ahead and use the screws that they sent with. They match the black boards pretty nicely, so I'm satisfied with that. When we go ahead and put the shell back together, though, I'm going to opt to reuse the tri-wing screws. If we look at this, we do not have as many screws as we did on the original I/O board, but the ones that we do have are in the same spots as they were originally, so most of them are down here toward the bottom. Let's go ahead and get those put in. Alright, all the screws are in on the I/O board. If we're looking at that now, good feeling on all the D-pad buttons. Start and select feel good. A and B feel good. Now we just have to contend with this one ribbon cable here and get that slotted into the retention connector right here. Go ahead and very carefully get that flipped up. And it should just be a matter of... I actually need to grab some tweezers for that. One moment. There we go. Okay. That was fighting me a little. But we did finally get it in there. Okay, the next thing that we need to do is make sure that everything with this assembly is working correctly before we put the rest of the components in the back shell. So what we're going to do here is I'm going to set that aside. I'm going to take CPU and power board. I'm just going to temporarily place it back in the back shell here, because these two shell halves, even though they're manufactured at different times, are the same, so they should fit together okay. We're just going to go ahead and put that back in here, and then put the ribbon cable in between here and the new I/O board, and then we're going to power the thing on and make sure it's working correctly. Alright, we've got CPU and power board placed back in the shell. We've got a set of batteries in this. And then we've got the new I/O board assembly on the front here. We've got the new ribbon cable that was sent with it. And it does not have a polarity per se. This is a straight through cable, so you can't really plug it in the wrong way as far as this orientation goes. However, you can plug it in the wrong way as far as this goes. If we're taking a look at this from the stance of the original one, as this would sit on here, the pins go face up like this. So we're going to go ahead and plug that in to the board here in that orientation. This is just a friction fit connector, so there's no retention clip on it. You just have to make sure that you've got it in there all the way. Then we need to double check the orientation for the connector on this side before we plug it in. If I'm looking at this correctly, as it stands right here, this can really only go in this orientation with the pins up on this side as well, simply because it's going to have to be folded in like that, and it's not possible for it to twist in any other direction. So let's go ahead and get that plugged in. Go ahead and stick a cartridge back in here so we've got something to test with. And very gingerly, so that we're not potentially shorting anything against anything else, we're going to go ahead and flip the power on. Sweet. Well, that confirms for me that the I/O board and the new display are working correctly, because we've got sound and we've got display. Perfect. Okay, now we can move on to putting the CPU and power board into the new rear shell. Let's go ahead and do that next. Now, we did not use any screws when we tested this, so this should just lift right back on out and slap right into the new shell without any sort of fuss or muss. And that looks to be the case. One thing that we will need to do is I will need to grab the new power switch before we screw anything back together. This has got a tab on it that faces down to lock the cartridge in when you flip the power button on. I have to lift that out, get that lined up against the switch, and then place back down. Seems good. Okay, let's go ahead and put the screws back in now. Actually need to pause at this point, because I'm just remembering. Pull the back of this off. We've got terminals to contend with now. Those actually have to be removed, because this new power board with the lithium-ion battery only uses plus and minus terminals on the actual board itself. So these other ones need to be removed from here. The way that we do that, should just be able to use these tweezers to press in on the little retaining clip, and it should just pop right on out. It's all out of there. Now we can go ahead and screw down the head jack board, or the headphone board. Rear shell is now back together. Now we can move on to the battery. Okay, as it stands right now, it looks like the battery with the power board is expected to be mounted in this compartment in this orientation. The plug right here. So let's go ahead and get this plugged in. You know, it strikes me we may need to actually take the board back out of here and get the spring off in order for this to function correctly. Let's give that a go. Alright, we got the spring out, which means I preserved the spring, and if I ever decide to put this back to stock, I can just put the spring back in on that contact. Now, I can go ahead and put the board in. Alright, now we can try and get the new power board in here. There we go. Alright. We are in and up against the contacts now. Go ahead and plug in the board, plug in the battery to the board. Alright, we are plugged in. Now, this really does fit properly. When I go to put the battery the battery cover on, well, it almost is in the right spot. There we go. Okay. We're in there and in the right position now. Should be able to charge that battery. Now we're going to do the same test that we did earlier. Make sure we haven't screwed anything up. Okay, we're back together. Battery covers on, I/O board's plugged in. Go ahead and put a cartridge in. Now if we flip the switch on, I not get the... Maybe not had the cartridge all the way in. Let's try that again. That's better. Sweet. We're going to go ahead and take the cartridge back out, and now we should be at a point where we can go ahead and put the shell back together. Well, like a complete dork, I completely forgot the last two screws are under the battery compartment. So we're going to have to pop that out, take the new battery board out of here, and then put those in, and then put the battery board back. Lined up. All right. We are back together now. Everything should be working. Go ahead and flip the power on. And that is normal because we don't have a cartridge in there right now. So this portion of the project is done. Now we've got one more thing that we need to do before we move on, and that is we need to get this part and double check to see how the battery is on it. I want to say that this takes one of these 3.8 mil game cartridge bits to take apart from the looks of what's in there. Give that a try. Yep, looks right. Screw out. Set that aside. On the cartridge face, yep, cartridge face slides down, comes off. I can tell already this is untouched. This has never had a replacement battery put in it, just based on how this looks. Now, if I grab my multimeter here, when this battery's new, this should read I think it's 3 volts even, or maybe just a little over. If it's under 3 volts, then the battery is dead for all intents and purposes. This is important because on a lot of these cartridges from this generation, these didn't have EEPROM to do save states for the game. They had basically the equivalent of low voltage RAM. So when this battery dies, the saves will either go away completely or they'll corrupt and the game will stop functioning correctly. So let's go ahead and take a reading. Yeah, we're actually reading 3.05 volts, so this battery is still good, which is kind of shocking. I suppose this could be an aftermarket replacement battery, but I have not seen a battery that looked quite like this. This almost looks like the original. So we'll go ahead and put this back together and we should be finished. All right, let's give this a go. Perfect. We're in good working condition now. Anyway, I mentioned, actually I'll turn this off first. Actually no, I won't take the cartridge out. We'll just turn the volume down. How about that? All right, no volume. Now I had mentioned we had contrast on here originally. And what that does now, if you're turning this up and down, is it turns the brightness on the screen up and down. But I said that this had a press button on it. What that does is it changes the color mode on the screen. So you can use this in original black and white, or you can change the color background on it. Now, this was not... Pokemon Red and Blue were not originally color games, so this is color emulation. It's just doing its best with a pre-programmed set of variables to emulate what it thinks the colors may have been on the game. Excellent. All right, we are done here. Well, it's now been a few days since I finished this, and I have to say I'm pretty pleased with how it turned out. I appreciate you watching. If you like this video, please like it. If you like this type of content in general, please subscribe, and stay tuned for more repair and modification videos coming up in the near future. Until next time.